I'm going to talk to you about the experience I had when I was teaching in the autumn quarter last year for the first time using ChatGPT. And I'll tell you what course I teach and the experience that I had teaching the students and the problems that we have. So I'm a statistician, and I teach statistics to PhD students in biology mostly. And they need complex statistics, and so it's very difficult. They need to use the computer. It's many things that have to be learned at the same time. So it's a very challenging course. And I found that ChatGPT made it much, much easier for the students. And my course is centered around real data sets, and they can be quite messy and difficult to analyze. So here are the challenges, I would say, when I work from the data upwards. So we work what I call ground up. We start with the data and then we work to the model. And the data are very heterogeneous. And the other thing that is very heterogeneous, which is very different, is the training background of the different people in the class. So I have about a third of the students are medical doctors who do research. And I have a third of the people who are PhD students in other parts of biology. And then maybe a third of the students have a background in bioinformatics. So it's very different background. And the strategies that we have when we're analyzing data, they have to be very flexible. So they're what we call adaptive. They adapt to the different data. And so we have lots of choices of methods and interpretation, and we interact with the data, and you don't want to lose any information. So the last big challenge today in biology is what we call reproducible research. And that is to have a supplement which gives you a complete scientific record. Reproducibility is key because there are so many choices that you can make. The only way of explaining your analysis is to allow the reader to redo the analysis. So when I talk about abstract problems, for me, here is a concrete problem. I work a lot in what's called the microbiome, the human microbiome, where we look at the different species of bacteria in the gut. And we have all of these different data types, images and mass spec and DNA, immune profile, a lot of environmental data. And then we have to integrate domain knowledge, which is very often networks, phylogenetic trees, or gene ontologies. So in this type of case study that I'm doing, for instance, with the Gates Foundation, we have things about the immune system of the host. We have the viruses that are present. We have the bacteria. We have mass spec, and then we have all of this demographics and clinical history. So these are the kinds of problems that biologists are trying to do. And it's at the cutting edge, really, of data structures and statistics. And of course, biologists don't want to spend 2 years training in statistics. They want to take one course and they learn all of this. So that's the challenge. Now we have classes and we know how to do this in theory, but it's a question about how do you teach somebody to do it in 10 weeks. So I use ChatGPT, and in some sense, there are ways of using it really well. And one is that buzzwords are really important. The words that you use are going to help ChatGPT find the part of the embedding which is relevant to you. So you have to say, what are you doing? And you must use the technical buzzword so that it knows your level of competency. And sometimes I find that people think, oh, I have to paraphrase. It's like talking to a child. And that's a mistake. You have to use the buzzword because you want it to be technical and you want it to understand that. And then you have to know what to be asking in terms of data structures and types and lists. So those are things that the students have to learn in the class. And then we do a few exemplary workflows where they know the data and they can understand the new methods on known data. So you can't do unknown data and an unknown method because that makes two unknowns and they cancel each other out. So you can't follow. And then we also provide training in what's called reproducible research so that the charts or figures that you make, you can make them again and again so that they're reusable. And this is a standard nowadays in modern data structures to do something which is called fair practices, which are findable, accessible, interoperable, reusable. And of course, the preparation is the students have to know one of the computer languages. So mostly I use R, but it's also possible to use Python because ChatGPT will translate back and forth between Python and R very easily. And we do a few test workflows on synthetic data, which we simulate where we know what's going on. So we prepare ourselves that way. Now, as I said, buzzwords are really important. So we use the technical words like hidden Markov models or bootstrap or non-parametric or Bayesian, because this will make the answers very, very useful and much more targeted. It's not that they're always right. That is, ChatGPT does still make mistakes, and you can challenge it and cross, and that's always a very good learning practice. So, for instance, for the students, we give homeworks. Regularly, we ask them in the homework, one of the questions is, tell me a mistake that ChatGPT made this week while you were working with it, or what was some code which was wrong and why. And so they learn from ChatGPT's mistakes as much as they learn from their own. The other thing about working with ChatGPT is, as I said, you have to stay technical. So one of the standard errors that people make is when they're computing probabilities, we have an intuitive notion of probability, which is often wrong. And an example of that is asking, so for instance, there's a standard problem in psychology where we say, we know that Linda is a student and she's very active in protest movement and she's a feminist and she graduates and gets a job. And what is more likely? One is Linda works at a bank, is a bank teller. And the other alternative is Linda is a bank teller and she stays active in a women's group. And if you ask psychology students what's more likely, they will say Linda is a bank and is still active in a women's group. Although from a mathematical viewpoint, that's incorrect because it's a smaller set. It's a more constrained, so it's a smaller set. If you ask ChatGPT, it also makes the mistake if you say more likely. But if you ask it what's more probable, then it gets it right. Then it's correct. And the reason for that is that ChatGPT, when you're looking at more likely, it's going to be as human as possible. And so it'll try and, in some sense, it makes human mistakes. And if you say probable, it will think probability, mathematics. So I have to give an answer which is correct. So there are subtle synonyms, choices of words, which are very important to do when you're doing ChatGPT. And the other problem that we have is that, for instance, in statistics, if you're not technical, if you don't put yourself in the area, in some sense, of the space or the embedding space of language, where it knows that you're doing statistics, if you use some of the words that we use, so for instance, bias, mixture, multimodal, those all have meanings in everyday life that don't have anything to do with the actual meaning that we want to use. And so that induces also error. So you must try to focus the questions so that we know that we're in technical space. So careful with the synonyms. And then the other thing is we try not to have too many blind pipelines, not too many black boxes. And for that, you ask, how can large language models help? Well, one is, when you're writing code, it's very good at documenting. And even, for instance, now we use with our studio and GitHub, there's an automatic ChatGPT in it. And we write the beginning of a comment, and then ChatGPT will complete the comment, and from the comment, we'll write the code. And the students found that very, very empowering, because it took them much less time to just correct what ChatGPT had written rather than writing all the code from scratch. I'm going to give you a quick example of how in biology it's been really important. So at Stanford, we lost our president to a problem of image manipulation. And what happens is that many biology papers, and I don't know how many of you are biologists, but many biology papers are published with images which have been, let's say, they've been changed by Photoshop. And Photoshop does a lot of black box things which people don't understand. The cleanup which is done, and it can induce a lot of artifacts. So that's very bad. And image manipulation is seen as something which is scientific misconduct. And people will say, well, what's the alternative? That is, we're trying to clean up an image. And here, for instance, Photoshop did the following. It copied out, it decided that the spots had to be the same. So it just copied out the spots instead of... And that was supposed to be denoising, but in really it's image manipulation. So this is a problem. And of course, the paper had to be retracted. Now, then you can say, okay, what is the alternative? Well, you could ask ChatGPT, and here's the prompt. How could one clean up a biological image with reproducible code in R? And this is the answer. It said, cleaning or processing biological images is crucial. Manual adjustments in tools like Photoshop lack transparency, and R provides an opportunity. So this is ChatGPT speaking, but then it's generating the code. And it explained to me, it said, you have to install these packages, you have to read, and all of this was generated by ChatGPT. So the students who just started off by writing the prompt, how could one, they're given a complete answer that they can actually use in practice on an image. So it's very empowering. And so these are the normalizations that it suggests. It says you have to adjust contrast, you can filter the image, you can smooth the data, and you can generate all the code to do this so that it's reproducible. And so it's not the problem that it's bad to denoise an image. It's bad to manipulate an image without knowing what is going on. And so the takeaway, and this is, the first draft from ChatGPT, is that it's telling you should retain the originals, which is completely true. You should document everything. And you make your code script available, and you have to be transparent. So this is a case where ChatGPT was very, very positive and useful to the students. So that was, takeaways which are really useful. And then we generated a lot of, specialized data structures and a complete record. And I'm just going to say that today, the supplement for papers, so this is a paper that got published in the Royal Society, is like an iceberg. You see a published paper, which is, say, 10 pages long, and the complexity of data made it so there were more than 200 million ways of analyzing the data. And we generated a supplement which was 220 pages long. And this supplement, it's not generated by ChatGPT. It was computationally generated using R, and everything was commented. We did it by hand, but we wouldn't have been able to do it without these computational tools which allow you to provide a complete supplement record. So there's a new generation of papers where you have to keep all the original unprocessed raw data that you're going to make available online so that people can exactly reproduce all the steps that you did on your data and create comments and documentation, and you could be transparent about your data. And so I want to say that the resources for this training, we have lessons with the carpentries, with specialized, bioinformatics or bioconductor courses, and you can join communities. You don't have to, invent everything from scratch, but it's true that open source and ChatGPT and large language enable more transparency. And we've only been using it, it's 2 years hardly. There is a question. So you're in Algarve, and I know, because I live not so far away, that water is very important. And so what I tell my students is a conversation with ChatGPT can be the equivalent of throwing a bottle of water away. So you have to think before you're writing the prompt. And you should keep your history so you don't lose your work and have to start again and again. Because many students, sometimes they think, oh, it's free, so I can just, use it. Well, that's a bad practice. You want to think very carefully about what you're doing, and you want to you try to be parsimonious and precise. So there is a suspect. So, in fact, I say that ChatGPT in the US, we grade our students A+, A-, B+, B, B-. So I say that ChatGPT is an A- student. It's not an A+ student, doesn't get everything right, but it does get a lot right. So I gave it all the homeworks to do, for instance, and it would have gotten about an A- grade. And here was just some examples of things that you can ask ChatGPT, which provide very, very useful ideas. And the last thing I wanted to say that help the students understand how to use large language models is to understand a little bit about how they work. That is, in this case, words and sentences are data, and they're organized into topics for this data, and the topics use tokens. Tokens aren't exactly words. They can be assembles of 2 or 3 words, or they can be actually half words, but they're embedded in a low-dimensional manifold, in a low-dimensional space. And you have to think of this space as a geography, like an atlas, and you want to make ChatGPT go to the right corner of the country for you, so that you're going locally and you get much better answers if you're in the right part of the embedding. So, the 6 essential steps, you can ask ChatGPT the question, could you explain what are the 6 essential steps? And you could ask it to be open about, how it works. And then you could ask that question. I'm not going to go into the details. You know how to use it. So you could ask, what are the 6 essential steps? And that way you can open up the black box a little bit. So, the training of the models, which is very, very expensive, is the data collection and the pre-processing. We can't do anything about that. The models have all been trained. And What we're doing is we're just using and evaluating. So, there's a regularization and evaluation and fine-tuning. So in the deployment and scaling, when you understand how it works, then you can sort of understand that you have to focus on the area. And for instance, I often tell the students, tell GPT chat, I'm a student in a statistics class at the master's level, and I know about this. So you can tell ChatGPT where to go in the embedding, so it gives you the most useful answers, so that you don't have to have too much of a long discussion. Okay, I could talk forever about this, but I will stop here because I don't want to, take up all your time. I want to thank you, Eduardo and Isabel, for inviting me. And also, I'm very thankful to the community, the open source community of R and Bioconductor, of who I use all the work. And of course, ChatGPT, which has been, is a useful tool for all of us. So thank you for the opportunity to talk to you. And I look forward to trying to listen to some of what you have to say, if I can, in Portuguese. And if you have any questions, I'm happy to take any questions.